Hey guys, today we're going to be talking about the Euclidean algorithm. So, the Euclidean algorithm helps us find the greatest common divisor of two numbers. Well, first of all, what is the greatest common divisor? Well, the greatest common divisor is the divisor that goes into both numbers and it's the greatest. So say we have two numbers 12 and 16. The greatest common divisor, or short form GCD, would be 4 because we know that 3 times 4 gives us 12 and we know 4 times 4 gives us 16. And 4 is the greatest number that can achieve this. We know that, well, of course we know they're both even numbers, like we know 2 times 6 gives us 12, and we know 2 times 8 gives us 16. Yeah, 2 is common for both. However, 4 is greater than 2, and this is the greatest number that can achieve this, so hence the GCD is equal to 4. So now we're going to actually find the GCD using the Euclidean algorithm. Okay, so first, before we start, actually, you know what, we're going to start, we write 16 right here, okay? 16, this is a bigger number because GCD, wait, let's just write the two numbers like that. So 16 is the greater number, so we have to write 16 first, and then we have to write a bracket here because we need to insert some sort of number here, and then we write 12. So our two numbers, 12 and 16, just like that. Now, we also have to add another number right here, okay? So we have to write a number here, the biggest number possible that we can use, kind of like, yeah, that we can use, and then add another number so that we can make this expression true. Okay, well, we don't like trial and error. I mean, I don't like trial and error. You could recognize right away, oh, like 1 times 12, okay, and then we can add 4. Yeah, like these were simple numbers, it's easy. But if you had larger numbers, I mean, I would say this is a better strategy. Here's what I would do. I would first take this large number, 16, and divide it by 12, the smaller number. So if you were to plug 16 divided by 12 on your calculator, you should get 1.3333333 repeating, right? You can write like this. And we're going to take the whole number of that. So we're going to take this 1, the whole number, okay? So we're just going to take that whole number, and we're going to write it in right here, okay? So see why this is 1? It's because it comes right from here. Now, what we're going to do next is we're going to recognize that, oh, well, we're going to do 1 times 12, right? And we're going to get 12, okay? And then we're going to say, okay, well, we need to find this blank number. So pretend we didn't find a blank number 4 yet. Well, what we would do is we would take 16, which is the larger number, we would subtract 12, and we would get 4. And so therefore, this number would be 4, right here. Okay, and now we're going to repeat the process. This time, we're going to bring this 4, and we're going to put it right here. And we're going to take this 12, we're going to put it right here in place of the 16. Okay, so in place of the box, this 4 goes right here. In place of this box, 12 goes right here. Okay, so these are kind of like our new boxes. You can think of it that way. And then now we just repeat the same process. So we do 12 divided by 4. Well, obviously you know it's 3. Right, so we know it's 3. We just write in 3 right here. However, this is a whole number, unlike before. So we know that the remainder is 0. Since the remainder is 0, this tells us that we have completed it. And now we just need to find GCD, which is the number right here, 4. It is always the number that's right beside the 0 like this. So this is our GCD. However, how about if we had larger numbers to deal with? Larger numbers. Okay, how do we find a GCD for that? Okay, let's look at an example. So for example, we have to find a GCD of 725. 65 like this. Okay, what is the GCD for this? Okay, so for this part, first we have to write the bigger number first. Always bigger number comes first. Then we write a bracket, and then we write 65, which is the smaller number. Put these in boxes to recognize that these are the two numbers. And then we have to add some sort of number. Okay, so since they're bigger numbers, I would recommend just dividing it right away. So 725 divided by 65. Now, if you plug this number right into your calculator, you will get 11.15 and so on. So we will just take the whole number of that, which is 11, and we will write 11 right here. Okay, well, 11 times 65, we're going to compute that next because we don't really know what this number is, so we're going to do 11 times 65. If you plug this in your calculator, you'll get 715. Okay, now we find 715. Well, obviously, this part's going to be 715. Well, obviously 715 is not equal to 725. So we're going to have to find out what we need to add to get that. So we're going to subtract 715, and we're going to get 10. So we're going to write 10 right here. And then now we have to bring these numbers like we did before. We're going to bring 65 right here. We're going to bring 10 right here. We have a bracket here plus something. Okay, so now we're going to do 65 divided by 10. So 65 divided by 10. Or you could write it like with a division sign, it doesn't really matter. Plug that in your calculator, you'll get 6.5. So 6.5, okay, well we're going to take the whole number of that, which we're going to take 6. So we're going to write 6 right here. Okay, well what's 6 times 10 now? We do 6 times 10 to find out what the remainder is. We get 60, that's not our remainder. Well, we're going to subtract it from 65 to find the remainder. So 65 minus 60, we get 5. So this remainder is 5. Now, what we're going to do next is we're going to repeat this process. So we're going to bring this right here. And then we're going to repeat this process. So we do 10 divided by 5. And we will get 2. So we're going to write 2 right here. And we know that, oh wait, well this is a whole number. It's a whole number. 2 is a whole number. So if 2 is a whole number, that means 10 divided by 5 gives you the whole number. Well then 10 is divisible by 5 then. So we could just write 0 right here. Okay, so we basically complete our Euclidean algorithm. Now, the number right here, this number that I circled, this number is our GCD because it's right beside the 0, or you can say it's this number. GCD is 725, 65 gives us 5. So 5 is our greatest common divisor in this case.